Hey, I'm Justin Frazee, a senior hard surface artist. And if you're a hard surface artist that's spending a lot of your time with traditional box modeling, sub D modeling, cleaning up low poly models, using Zbrush to polish high density meshes, or spending a lot of time on tedious UV mapping, I think I have some tips that will save you some time. If you've done enough polygonal modeling, you know that half the time you're just fighting your topology instead of making shapes. Let's use some software that's not going to waste our time. Now, Plasticity is a CAD modeling software made for artists. There's no topology to really worry about. You'll have to get used to a very different workflow than your polygons because it's CAD, but once you do that, you're just never going to go back. Now, Plasticity is great at creating hard surface shapes, but there's still a hiccup when you go to export your mesh. Translating the CAD model into polygons can turn into a mess. That's where PyXYZ comes in. It has a great CAD conversion algorithm and can take your model 90% of the way to your low poly, so you only have a little manual cleanup to do. It also exports as an FBX instead of just an OBJ, which preserves your hard edges, and that will come in especially handy when we go to do our UVs. You can add isoparms and plasticity to help control where your edge loops go. Just export a step file from plasticity, then tessellate in PyXYZ, export an FBX out of there, and import it into Maya. Just make sure you use the Unlock Hard Edges option on the FBX import. Once we've brought the mesh into Maya, there's always going to be some amount of cleanup to do, but it's considerably less than if you just exported an OBJ out of plasticity. Plus, we get to leverage those hard edges we get from the FBX export. I have a set of scripts I use to UV map that utilizes the hard edges. I just have to select the mesh, run the script, invert the selection, run the rest of the script, and I'm already most of the way done. The one workflow quirk is you have to put a hard edge anywhere you want a UV seam. So most people won't put a hard edge on a cylinder, but I do, just so that my script works the way I want it to. When you go to bake it, that hard edge disappears, and the oddity of having to add a hard edge to a round face is well worth the extra speed you gain by doing it. The way the script works isn't magic. It's just standard tools that I've combined into one script. So you can replicate it yourself if you wanted to, even in another 3D software. It does an auto unwrap, selects hard edges, and cuts the UVs on those hard edges. Then you select the inverse manually, and it sews all the other edges together, unfolds and orients the shells, then scales them to the same texel density. You'll want to do some things manually, like stack islands or do some additional orientation or straightening, but it's a big lift for free. Once I'm done UV mapping, I just export a high poly out of plasticity. Typically, it can be the same model as the low poly, but if there's additional details you want to include, that's a good time to do it. An OBJ is fine, and I just crank up the settings to get a super dense mesh and capture all the curvature. Now it's on to Marmoset 5 and its bevel shader magic. Set your bevels based on material or object and bake it down to your low poly. And now, you're done and ready for texturing. If you aren't keeping track of the time we've saved, let me recap. We've cut out the annoying part of modeling, increasing our speed there, eliminated about 90% of the time on low poly cleanup, cut out 60 to 90% of possible UV mapping time, and completely eliminated the need to do a high poly at all. Now there's always going to be cases where this workflow isn't the correct one and you'll need to use those old methods and tools, but I've adopted this as my typical go-to workflow, and it saves me huge chunks of time, and I hope it helps you too.